Okay, so let me tell you a little about today's talk and our guest speakers. The aim of our core, which is Core C, is to assist investigators in using the best possible statistical methods in their research. And one way we do this is through consultation and collaboration. So today we just want to highlight one successful collaboration between a KC investigator, Dr. Paul Yoder, and one of the core members, John Tapp. And we're going to provide a real-world research application of the Moose's observation system. So that's what we plan to do today. John Tapp and Paul Yoder have many years of experience working together and separately on direct observation projects. John is an observation methods and reliability specialist, and he's currently the director of information technology. And Dr. Paul Yoder is a professor of special education here at Vanderbilt, and he has written a text on and teaches a course on observational measurement. So please join me in welcoming them today.
Thanks a bunch. I'm going to start out by blatantly plugging this Yoder book right here. If you guys haven't read this book, you need to. If you're going to do observation, you need this book. Yoder and Simons. Paul took a sabbatical and wrote this, right, Paul? In New Zealand, right? Among mountain climbing. But to say that our collaboration is successful is kind of an understatement. I've known Paul for what? How long have you been here? 20 years?
6 years.
26 years. And we've known each other from the old days in Hobbs, and we worked on so many projects together on so many different computers. It's pretty amazing. We've done so much together, and I really appreciate him and what he's done and how he's helped me, and I hope he appreciates how I've helped him. I wanted to do a little history. I mean, how many of you know what Moose? I know a lot of you know what Moose's is, but some of you don't know anything about it. So I want to do a little history. This is a slide that I put up just to highlight that I like science. I'm a staff member, really. I'm not a faculty, but I like science, and I'm a big fan of Einstein. And that's a quote. I won't read it to you, but he's talking about observation, and the point here is that it's important to observe, I think. You can ask teachers and parents about the kids. You can get reports from other people about things, behaviors and whatnot, but seeing them is really better if you can do it. So my goal in a lot of the software I've done over the years is to try to make it easier to quantify observation data in all kinds of different studies. I started at Clover Bottom Developmental Center doing research studies on self-injurious behavior and stereotypy, which is repetitive movements. We did a bunch of the original methods on the PDP 1140, which was over at Peabody, with literally punch cards and Fortran punch cards. It used to take 3 passes to run a sequential analysis. It would, and we'd have to do 3 different programs because one wouldn't fit in memory. And the process was write your code, run the stack through, get your errors the next day because you can't use the computer during the day. It was too important. You could use it at night. So, and then go fix your errors. And so writing a program back then would take me months, literally months. And then the Apple II came out, and we were so happy that we could just do it all right there in one little box. And then we ported this software to IBM PC. So this version 4 is probably really version 6 or 8 of different iterations of the software that I've written for different programs. And the one right now is for Windows, and then the latest paradigm shift that I'm dealing with is the cloud. Microsoft has just started the Microsoft Store, the Surface tablet, the collector will need to be on that, and it has to be in the Microsoft Store, so we have to deal with the cloud now. And like she had said, I do IT strategic planning. I'm the webmaster for the Kennedy Center, but I also do software development, so that's what we're talking about today. Pass this around. This is what I used at Clover Bottom, called a data mite. It would only take numbers. this is my soapbox. Get Yoder's book. Don't do an observation system because somebody else did it. I mean, I don't know, maybe Paul can talk a little bit about that, but what I see is a lot of people taking an observation system that doesn't really fit their research question and kind of using it just because it's there already. So, and don't collect too much. People tend to try to collect, just because I'm collecting, I'm going to collect everything that I can collect. Well, then you don't get anything in the end. So that's my soapbox. This system can handle momentary time sampling or interval systems, timed intervals, partial intervals. You can collect data that way. You can collect data when it happens, you hit a code, and it marks the exact time that when it happens, and I call that real-time data, or timed event data is Paul's term. We had lots of debates about this in the early years in the 80s and 90s about what was best, and people did timed intervals because it was easy to do with a stopwatch and a piece of paper in your hand. So we tried to argue that it's better to code when it happens with the data mite. You just enter a 1 or a 2 or something. And now I think we're coming back around to where, especially with Procoder, where the time can stop, where an interval system is really a useful thing. It's really a good way to go, and for a lot of research questions. So I used to argue more for real time, but now I'm kind of liking both of them, depending on the research question, whatever you, and really boils down to real time is really just making the intervals smaller. These are the data collection options that we have for Mooses. This version of Mooses is rolling out today. I feel good about it. I feel like the data's right in it. Finally, I've been working on it for 2 years, at least, maybe 3. Microsoft changed their basic programming languages so that I had to rewrite it from scratch, and so it's taken me forever. But these are the data collection options now for the program that I'm calling for Lily for real-time collection. I'll show you in a minute. Joe Webby does more classroom stuff. Paul always uses tape, and I'm always like this with them, trying to compromise on whether or not which one the best way to go is. It's sometimes hard to get video because in classrooms it's just a pain. So there's a lot of people using this with a real-time collector in their hand. And then Procoder is the platform we're using to collect data for it with video. We like for our codes to be mutually exclusive, exhaustive if we're doing the codes when it happens for duration codes, but we also have the count codes in the book. We're calling that the metric. Count versus duration is the metric for that coding category. For interval collection, again, we observe for a set amount of time. With Procoder, the tape can stop and you can make your ratings and then play the next segment of tape or video. Some people will do this in real time with a partial interval. They'll watch a section of time and then code for a section of time and then watch for a section of time. But this new system can support all that kind of data in the one program, which is was one of my goals with it. So I don't have so many different programs running around. Again, we like to have mutually exclusive, exhaustive coding spaces, but we don't have to have that. It can deal with it either way. I'm going to do that in a minute. Procoder, we have digital video, and I wrote Procoder to talk to players. So it talks to Windows Media Player. It talks to a player that I bought. Well, the problem with that is I didn't write the player, and the players don't always work. And the codecs inside of Windows don't always work, and they're always a little bit different. So sometimes we have to translate. Most of the time I'll say it just works. Sometimes it doesn't. So there's a lot of voodoo with video that when I got into Procoder, I thought, this will be easy. It's not been easy, and the problems that I've had with it have been not my fault, basically. But it's hard to say that when they're using my software. So I can talk about Teddy, talk about Procoder a little bit. We first came up with this because a guy named, was it George House or Howe? George Howe? He had this video control stuff for Apple II sitting in his office. He left. It was very expensive. Teddy was sitting there with a remote control in her hand in front of a television with a videotape trying to code things and being very frustrated. She said, can't I use George's stuff to code things? And we said, well, okay, let's try that. And the software that was with it was horrible, and it didn't do what we wanted. So Carol Hamlet, who works for the Fuchs now, is still here, and I wrote Apple II Procoder, the very first version on Apple II, to run videotape controllers. And it worked really well. We used it for several studies and probably used it up till 2001 or so. It was for DOS, but it ran in Windows. And then, again, not my fault, Panasonic said, we're not making these big tape decks anymore, sorry. You're not going to be able to do this anymore. So I wrote it over for Windows and then got into the codec issues and whatnot. I'm not going to go too much into what Procoder does. I'll show you in a minute just so you'll get an idea. I'm going to just go over some of the analysis real quick that Mooses will do. Some of those are in the old one, and I haven't put them in the new one yet. But it'll send output to comma-separated files and to the screen. I'm going to let Paul talk about inter-observer agreement. I'm not going to go into that, but there's a new method that is in the book that we used. So we're calling it non-exhaustive or exhaustive. And hopefully he'll describe that a little bit, but it's in the book. It'll do sequential analysis, which is given a code happen, what's the, I want to use the proper terms, what's the chance of another code happening is kind of the idea. Given something happened, like you tell a guy in a group home, Johnny, tie your shoes, and he hits himself. Ah! This was one of Frank's studies, and I use it for an example all the time. Well, we want to know, does he hit himself more after you prompt him to tie his shoe or prompt him to do something than he just would normally hit himself and just sitting there? So the sequential analysis is designed to answer that kind of research question. What happens after other things? It was originally thought up by Bakeman and Gottman to do couples research. When he says something, she says something. When he says something, she says something. The event sequential was based on that, and it was really good for that because it was always turn taken. There was usually he said, she said, he said, she said. Over the years, we've had studies where that, with parents and kids, where that kind of holds up, and the event sequential analysis was designed to deal with that, and it does it very well. But for most research questions that we see, like the Johnny hitting himself after he's prompted to tie a shoe, it really doesn't, because there's other codes in the way, and we want to just know, did something happen in the next little bit of time. So we have the window method that we've done a lot of research on, and that's in the book. But there's just and then we use Yule's Q as an index of the level of this relationship of sequence. And then there's a z-score, which is an indication of the validity of the power or the validity of the Yule's Q. Is that about right, Paul? How would you? Yeah. So Yule's Q is the index that we normally use. I'm not going to go into this too much because when you need to know it, we'll go into it. Yeah. This is basically about the counting. All I want to say about it is The event counting is counting events, and the time counting is saying is it a given code? Is the next one a target code? The time counting is counting time. It's counting is the target in the window or not? Is there a target there or not? It's a major difference, and people don't really understand it. So talked about that a little bit. Oh, it does nested frequencies. So one of Joe's common questions is there more aggression when the teacher's gone? And so you can do things like, what's the level of aggression when the teacher's there versus when the teacher's not? That's a nested question. Oops. So I've got about 5 minutes to do a little bit of demo. This is some other software that does kind of the same thing that's out there. Observer from Nolus does the same thing. GSeek, Bakeman, is it still used a lot, you think? Yeah. And Transana was developed somewhere around here and for transcript analysis, and people are using it. SALT is a good system for analysis of language transcripts, different things about language, and they use that daily here. These are the URLs for the commercial sites for the programs, but we'll send you that when we send you an email. And I'll send you download links to the demo versions of the programs. You can just download them. So I want to show them a little bit just so you get a feel for what they are. So I'm going to look at Procoder first. Just going to open a file. I was coding Janet Jackson's Smiles when I was developing this. I was using digital music files because, let's face it, kids screaming is not that much fun. So I just wanted to show you that how this works. So if I marked a smile here, and if I just want to go to it, there's the smile. I just clicked seek. So what Procoder does is lets you get the time from a video, store it, go back to it, replay it repeatedly, and just to show you that it replays the same thing every time. And seek things. The other really cool thing you can do with it is play a chunk of time and stop. Play a chunk of time and stop. Make some ratings. Paul does that in some of his studies. Some of his studies he uses the mark when it happens. Kind of depends on the research study, and we like to look at your research study before you do observation if we can. I especially do, to try to head off any kind of problems that you might have. So please come see me if you need that. Then I'm going to look at mooses a little bit. I want to highlight kind of what's different for some of the people that have used it before. The old one, you would do an analysis by just saying, I want to do an analysis. Then you would go pick the file. You have to go find the file or pick a list. It had a list editor in it, and then you'd answer some questions about the analysis. This is the old one, and I thought that was a little bit inefficient when I redesigned, so let's see if I can do one real quick. This is demo data. So there's frequency and duration for that test file I have. It's kind of the same process in the new mooses. Except instead of list, I came up with a concept that I call a file set. And you make the file sets by dragging the files in there and underneath a pool. So files can be pooled. The analysis of files can be pooled into summations of it. But just for time, I already made a file set and just loaded it up. But these are 4 files that I had for demo purposes. And then the analysis settings stay every time you run. Before, you used to have to do it for every run. So the analysis settings get saved as preferences. So, and a lot of them are linked to the way the codes are set up. So that was better, I thought. And just to run the same analysis, I'm going to run that set through. So here's the frequency and duration report for all 4 files with pooled at the end. I also wanted to illustrate that it can go to a spreadsheet really easily by just picking that. Let's clear it just in case there's stuff in there. All right. And then it comes out in more rows per file with a pooled at the end. Most of the analysis do this, and then you would use that inside of a statistical program, SPSS or SAS or whatever, and do more analysis on it from there by session. We can look at what'd you do to me? We can look at a sequential analysis if you want, real quick. This is the settings for the sequential. You pick your given and target codes from your code file. You pick the type of sequential in the settings. And those persist, which is a change. And then you just run it. And there's the sequentials with my little test data and the pooled at the end. So what we were going to do is let me answer questions while Paul switches his laptop. If anybody has any. Does anybody have any about?
When you're running sets of files, is there a limit to how many you can do at once?
Not that I've run up against, no.
Okay. So
It'll run them.
Just put them all in there.
Yeah, you just drop them all in there. Now you can pool them in sets. So an example would be if you want if you're doing observations across a day, say, and you have 5, and then you want just the summation for a day, you can make separate pools, which was a new thing.
Okay.
So like you want to plot your days instead of your sessions, which is a cool thing. But so you can group them into pools, and that's why you would do something like that. But I haven't run into a limit. And there's a group. I need to have her test, but even with the old one, I haven't. There's a group in Louisville that had 400 or 500 files, and it ran them in a couple of chunks, and it was fine. It really does them one at a time, so it's really not. There's really not a big memory drain on it. Anybody else have any questions about the software? Paul's going to talk about the discrepancy analysis.
Yep, I am. So reliability.
Are we on okay?
Reliability is cool, but discrepancy discussions are key. So I'm going to try to show you why discrepancy discussions are so easy now, to encourage you to do them more often. As far as I know, the new Moose's program is the only one that does the functions that I'm going to be talking about. I am going to be assuming that you know some terms, interval behavior sampling, timed event behavior sampling, metric, count, unitizing errors, classification errors, agreement matrices, and discrepancy discussions. So I'm going to go through, and I want you to raise your hand if you don't know a term. I'll define it if 3 or more of you don't know it. And then if there's just one, I'll ask you to talk to me afterwards. So interval behavior sample, raise your hand if you don't know about it. Okay? Timed event behavior sampling, fine. Metric, count, unitizing error. Unitizing error is one in which I see an event, but you don't. So a relevant event, an event that is a part of the coding system that you're coding. It's an error in the sense that we disagree on the occurrence of any relevant event occurring. I'll give you some examples about this later. That's in contrast to the next one, classification error, which is we both see an event, but we call them by different names, or we see them as different levels within a set of mutually exclusive codes. So for example, we both see an aggressive event, but I see it as personal aggression, and you see it as property destruction. Okay? Agreement matrices, discrepancy discussions. Okay, so there are a few of you who don't know many of the terms, and there is a glossary in the back here, so you can look at this, you can talk to me, you can probably get that at the library. All right, so one of the things that's new about the new MOOCs is it enables a better way to look at what we'll call the agreement matrix, which is the points on which these two coders agree. And then it allows us to look at both of these kinds of errors that happen when you look at agreement matrices, unitizing errors as well as classification errors within the same matrix, and you'll see how useful that is. It's really important to do this, and it's very helpful. It makes it clear that both coders are equally important, equally weighted. There isn't a primary coder and a secondary coder. There are two coders, and it's really important to weight them both equally. We could talk about that if you want to, but there's a really good reason, if you'll take my word for it for right now, to take that on faith if you don't agree on it yet. Most importantly, though, and that's what I'm going to hit the most, is that it gives a list of the discrepancies. It gives a list of where these two people disagree, either time by time, or like second by second, or interval by interval. And then it allows you to use the agreement matrix in concert with the discrepancy list to hit those most problematic decisions, coding decisions, when you're talking with each other to help you improve the accuracy of your coding and to keep observer drift from occurring. Okay? So in this next example, I'm going to be using a timed event behavior sampling. That's where we indicate exactly when an event particularly occurs. Okay? And the metric that I'm going to be talking about is count, just the number of times that a particular event occurs. This is a non-exhaustive coding, and thus agreement on the absence of an event is undefined. That's not clear to you yet. It will become clear very soon. However, it's still really important to know how many errors are made due to one coder indicating that an event of relevance, in other words, a codable event occurs, but the other one doesn't see a codable event there. Okay? And that's called a unitizing error. So here, this is an example on the left of an agreement matrix. It's a non-exhaustive coding. So if you look at the none for S, single word, you can see that the row, for example, the row, for example, is the file 1, the columns are file 2, and so you can see that there are an NA, non-applicable. Thank you. It's not applicable because there isn't any way to know the agreement on non-existence in a timed event approach. But it does allow you to see that most of the errors are due to, in fact, all the errors are due to someone seeing a smile, but someone else not seeing a smile. Okay? That's just an obvious example of a unitizing error. So So in this case, what we see is that coder 1 is slightly more liberal in coding smiles than coder 2. Okay? That's one way to use that approach. Yes?
Was the 24 the number they got that were the same?
Yes. So these agreement matrices are always set up such that the agreements are on this diagonal here, left to right diagonal, going down. So that's 24 instances in which they saw the smile occurring at the same time. Okay? And obviously, this isn't so good. This particular agreement ratio is not so good, about 46% agreement on a second-by-second level or point-by-point level. This is on an interval coding, an interval behavior sampling approach. And in this case, the non-occurrence of these two codes is defined. So because we're looking at 5-second intervals, we can say neither of us saw a relevant event occurring in this interval. So in this way, we can get unitizing agreement. And that's where the agreements are here. It also allows us to see unitizing disagreements. So when one person doesn't see either A or C in the interval, but another person does, it would be under none. Okay? A is an attentional lead in this case, so this is mother-child interaction, and an attentional lead is where you're responding to the child's attentional focus. Coder 2 is way more liberal than coder 1. So up here, we're seeing coder 2 is the columns. You can see that, that A codes way more attentional leads than coder 1. You see that? Because there's a lot more here. Okay? 10 disagreements due to coder A coding A, and when coder 2 codes none. So that tells you that there's, that we want to focus on this unitizing error, and it's mainly because this coder 2 is more liberal than coder 1. Okay, now what I really want to do is to focus on the software that we're trying to promote here, which is Moose's. Whoops, that's not it. Sorry. I've already got loaded these two files. These are interval files. I'm going to show you real quickly the way the code file is set up, very briefly. So I've just indicated what kind of sampling, behavior sampling method I have here. That's relevant to what the computer program does. What metric I'm interested in. For one of these codes, I'm interested in duration. Another, I'm interested in count. That's very useful. There's a nice link between the software and the concepts of observational measurement. And I think if you use the program, you'll see that as really helpful. I've indicated here that the input for this file is Procoder file. I've indicated that these are fixed interval data. I've indicated that I want an exhaustive accounting of the coding space. I've indicated I want the times of disagreement and the agreement matrices. Not quite sure why that happened. All right. So what I want to do here is to talk you through this really nice listing of disagreements. So what you'll see is well, actually, first, before I move on, I want to, so the agreement matrix tells you what categories and groups to focus on. You focus on the groups that have the most disagreements. And then within a group, or a group is a set of mutually exclusive codes. Okay? Within a group, you can then focus on the code that has the lowest agreement ratio, agreements over agreements plus disagreements. This provides a total accounting of the disagreed upon intervals. And you can see that some intervals, like this one, have only one listing, okay? When you have only one listing, it indicates that there's a unitizing disagreement. So you can see that 11576 has coder 1 indicating that it's a attentional lead, and coder 2 saying that there's no relevant event there, okay? But there are other times when there are two accountings of the same interval. That's a classifying error. So they're both codability decisions. They both see a relevant event, but one sees a high codability, one sees low codability. Then there are other situations where you have three of the same interval, and in this situation you have a classification error and a unitizing error. So here's the classification error, high versus low codability, and here's the unitizing error. One saw a response, one didn't see any relevant event. It's also possible to have more than three. You can have a whole bunch of them. So if you look at these here, you can see that there's a bunch of different differences or disagreements. There's a unitizing error for response. There's a codability classification error. There's a communication disagreement. No, sorry. An opportunity disagreement that has to do with communication versus attentional lead. So in a sense, what you're able to do is to get a sense of not only what categories and groups are problematic, but what intervals are real problematic. So you might want to focus on at certain times in your coding training period, you might want to first focus on categories and groups, in other words, concepts. But then as you get further into training your coders, there might be certain instances that keep cropping up, and you might want to be able to identify where those intervals are so you can work on, well, what is our coding system not accounting for yet? Maybe we, through discussion, can talk out this problematic interval and figure out how this should be coded, and then improve our coding system so that it becomes more transportable to other research labs. Then the next thing I wanted to show you was just how beautiful this works out in terms of leading to discrepancy discussions. And that's where we can open up the discrepancy list. Okay, so I've got some sort of closing down of the screen resolution changed, didn't it? I don't know why that changed.
Because of the projector.
I see. Okay. I'm going to have to live with this. A couple of things that I want you to notice, though, is that I've now sorted the discrepancy list by group 2, by category. So you can see that I've got all the codability disagreements sorted here. So that's what these are. I'm going to scroll down till now I'm getting to the opportunity for the response disagreements. Okay? And then within the opportunity, they're done sequentially, by time, in other words, okay? And so what I can do is I can say, okay, I want to focus on opportunity, and I'm finding that the really problematic area within opportunity is the A code, or the attentional lead. So what I can do is to go through these opportunities and play them. I'm going to click that. I'm going to go to Seek. Oh, one thing I wanted to show you before I start this is a really important thing to set up for Procoder, if you're going to use this feature, is you need to make sure that you have pre-roll, post-roll around the event checked. You need to indicate the pre-roll time for the length of your interval. If you don't do that, then what I'm about to show you won't work as smoothly as it can work. But once you've got that set up, and it's very easy to set up as long as you know to do it, and that's in the manual, is you seek that, and then you replay it. Okay, so that was 5 seconds that it played. And you can see why this was a real vague lead. In other words, you're trying to find out, what is the child looking at? It's all about what he's looking at. He's not touching anything. And so we can decide whether this should be an attentional lead, what we're going to call an intentional lead or not, you know? And we can go through each of these and do that. Same sort of thing. So you can see how efficient you could use this. You could really focus your discrepancy time for every single discrepant interval and build a concept of what an intentional lead is by pressing up against the edges of that concept, the hardest things to code, so that becomes more solidified. You see what I'm saying? And this is way better than we've ever been able to do before. And it's only enabled because of the kind of work that John can do. And he's created a tool here that is really easy to use. It's fast. It's set up in concert with, someone who makes his living doing this kind of thing, so that I have a sense about what it's going to take for people to move into really embracing the value of discrepancy discussions. So the reason why I'm talking about discrepancy discussions as being something that I have to convince people to do is because in general, it hasn't been something that's been done very often. You have any idea about why discrepancy discussions aren't used more often when they seem so obviously useful? I'd like your input on this.
It's too hard.
It's really hard. It's time-consuming as hell. Finding the right place, writing all that down. Nicole, how long does it take you to prepare for a discussion, a discrepancy discussion? I mean, and Nicole does this all day long. She's really good at it, And so if we could have a tool that became clearly useful, easily used, once you have the manual and you know how to do it, actually the interface is pretty intuitive. You just have to get over that first learning hump, which isn't that steep, particularly if you have a step-by-step manual, which we've created for you. So now I'd like to stop and just find out what your questions are. What would you like to know about, and what would you like for the new Mooses to be able to do that you haven't seen it do yet? Kristen. Yes. So the list of discrepancies is created by Mooses, and then it's used by Procoder.
Okay.
And it can only be used, the Procoder discrepancy list can only be used with a media file. So obviously, you can't conduct discrepancy discussions on live sessions,
Right.
because there's no media or event to center your discussion around.
Mm-hmm. But the demonstration you showed with Mooses, where you hit run analysis, will create this file through which you can run through Procoder?
Yes.
Okay.
That's correct. So the question was, does the new Mooses program create this discrepancy list and those agreement matrices? And the answer is yes. Yes.
Can you maybe demonstrate a little more how the actual coding software works and how you get these exact matching times
Yeah.
for both coders?
Yeah. Okay, so what I'm understanding the question to be is, how does the new Mooses identify these discrepancies It's very easy to talk about it in terms of intervals. Okay? So in terms of intervals, you know exactly what part of the tape is being coded. Okay? It's harder, but possible to do it with timed event. And I'm going to go through a timed event example because I wondered if that was going to come up here to talk a little bit about how that's done. Okay, what you'll see here is my using the software. I'm going to just drag in the original Procoder files from a primary and a reliability coder. I'm going to input a Procoder file. Sorry, did I do it too fast?
No, you already had imported it.
I did, but I want to show them how I set it up. So this was the Procoder file. It needs to be changed a little bit for the new mooses. I'm indicating what kind of sampling I'm using. I'm using a timed event sampling. And you do that for each of your codes and each of your groups. So remember, a group is a set of mutually exclusive codes. Some groups can have only a single code in them, and that's perfectly fine. There are reasons to do that have to do with how you set up and use your agreement matrix. Yep. You want to indicate what kind of metric that you're going to be using. Mostly, you'll find that this duration and count will be sufficient for what you want. So once you have your code file set up, you just indicate where you want to send this. I always skip the pooled. I'm not interested in pooled output myself. I'm going to be setting it on text. I've got a Procoder input, but I no longer have interval files. I'm going to be using the last and first times within the period. I do have an exhaustive accounting for duration because every second is considered, but I have a non-exhaustive consideration of the coding space for my counts because, again, we can't get agreement on non-occurrence. And that's important when we're thinking about an exhaustive coding space. Okay? I'm going to want both these times of disagreement and the agreement matrix. But notice this agreement window now becomes relevant because I don't expect there to be absolute perfect agreement by time. So it's the onset of, let's say I want a 1 second window. That means that within 1 second before and 1 second after, I'm going to call that an agreement. Okay? Now we can make this as big or as small as we want, but there are ramifications to that. And your decision about how big that agreement window needs to be is going to be informed by how you're going to use your data. If you're going to be doing a sequential analysis, then the timing of these events is really important. If you're not interested in a sequential analysis, but you're really just interested in a summary count of the events, and you want those to be as accurate as they can be, and you don't want observers to drift, then you might be willing to allow a bigger window, maybe as much as a 4 second window even. But there are some ramifications to having this window so big that it becomes no longer useful for discrepancy discussions. Do you see what I'm saying? Yeah. And so I'm going to keep it at 1 just to make a point. And I'm going to go ahead and run this. First off, I'll clear the file. Always a good idea to clear your file because I haven't converted to seconds. You do.
Well, you have to put 100 in there.
Yeah, so this will make a difference in what it calls an agreement. Thank you, John.
Procoder times are in hundredths of seconds, unless they're rounded. And mooses will round them with that when you check that box.
Oh, I hate when this happens. So this is the kind of thing that, every person who kind of rolls out a software sort of cringes at the possibility of happening.
Run it again.
Fortunately, what I did was I have a backup list.
That error is happening when you change code files midstream, and I haven't nailed it down. But I know what it is.
Okay, so this is the discrepancy list of that file. Believe it or not. And one thing that's really cool about it is that you've got not only the descriptions of the codes here and the groups. These are groups: single word, multi-word, nonverbal communication, and then later, somewhere in here we've got something else. But we also have transcriptions and comments that go along with that. And so if you have two people who have the same event, like here, 144, they found the same event, they classified differently, and now you can look at how they transcribed it. One person transcribed it as right here, one person transcribed it as X here. I'm not sure I hear right here. Do you see what I'm saying? So that kind of linking of comments with the event and having it set up side by side like that just makes discrepancy discussions so much easier. So much easier. Now, if you sort this by group 2, which happens to be the column label for the groups, and then within that by time, then what you can do is you can say, okay, so I've got most of my disagreements centering at single words. And then you can look at those single words. And you can say, okay, what am I mainly disagreeing on? Looks like a bunch of unitizing. Yep, whole bunch of unitizing errors. Mainly it's that someone hears something, someone doesn't hear a word. And that makes total sense, doesn't it? A lot of times these errors you may not be able to fix. You have to live with them. And you might end up having to say, we can't really make that distinction. Okay? But boy, you can see how this would really help you, can't you? Have I sold you? If I have, download the program. Get the manual. Nicole Thompson gets a lot of credit for helping create the details of the manual. We've got about 5 minutes left.
She helped me so much with debugging. Thanks.
Yeah. Anything else? Any other questions? All right. Thanks a lot for your attention.